Hello, so in this video we will talk about finite state automaton and language recognitions. Specifically, we will do some more examples uh, and see what kind of problems are encountered in this topic. Okay, so first of all, what we will say is, what is a finite state automaton? It does not have an output and it has some ending states. Okay, and what is a deterministic finite state automaton? A deterministic is one in which each state and input pair has a unique next state. Okay, so we'll still restrict our attention to deterministic finite state automaton. So the first kind of problems we will see is that we have a finite state automaton and we want to find whether a certain string is accepted by it or not, or recognized by it or not. Okay, so let's say whether this finite state automaton recognizes this or not. So what does this star means? This means cleans closure of this set, which is what? Which is union k is equal to 0 to infinity, this set to the power of k, which is what? 0 to the this set to the power of 0 is just empty string. This set to the power of 1 is what? Is just 0. Then for 2 is just 0 0, and so on. So we have a string of all zeros and we have an empty string here. Okay, so whether it is accepted by it or not. So it is accepted by it because empty string is accepted. We start with as a state where we have, which is also an ending state. So empty string is accepted and all zeros are accepted. Okay, so then this is good. So now what we check is whether this guy is accepted or not. This guy means what? 0 concatenated by the cleans closure of this. So this is exactly this, but empty string removed. So this is also accepted because all 0 string are accepted. So this is also good. Now what about the next one? So next one we'll choose 1 followed by the cleans closure of this. So which is what? Which is 1 because empty string for this, then 0 for this is 1 0, 1 0 0, 1, then any number of zeros. 0x, I can say. Any number of zeros. Now is this accepted or not? Note that 1 0 is accepted. 1 0 0 is accepted. So 1 followed by each any zeros is accepted. But the problem is this guy. If we have just 1, then we are in a non-accepting stage. So this is not accepted. Okay. Okay. So what about this guy? 0 1. Right. So this is what? So this is again, of course, empty string. And then 0 1, then 0 1 0 1, and 0 1 0 1 0 1. So all the strings which has 0 1 concatenated by itself. Okay, so is this accepted or not? Now note that this guy, this ending state should have a 0 to reach. So if we want to go to this ending state, we should have a 0 here. And this ending state, this guy, we cannot even reach it. So this means that you see all the arrows are actually going out from this state. So we cannot even reach this stage. So this, for this ending state or this final state, we should have a 0 in the end. But these strings, none of them has 0 in the end. So this is not accepted. Okay. What about this guy? 0 cleans closure, 1 cleans closure. So this means what? This can have 0, then 0 0 0, and I am taking empty string here, and so on. Then we have 0 1 0 0 1, and so on. And of course there are this is an empty string, so 1, and these also work. But then immediately when we have 1 here, we have already seen here that this is not accepted. So this guy is not accepted. Okay, and lastly, what about this guy? 0 1. Now immediately when I see this guy, I can see that I can make a string which ends at 1, correct? From this. And this guy starts with 1. Starting with 1 is not a problem. But the problem is that from here I can make a 0 1, right? And 0 1 we have seen that anything which ends at 1 is not accepted. So this is not accepted. So now you can see that checking whether a string is not accepted is easy. But checking whether it is accepted is a little bit hard. That's why we have simpler examples for these ones and simpler examples for the ones where we have acceptance or recognition. Okay. Okay. Let's go to another kind of problem in which we are given a language and we want to construct a finite state automaton. Okay, so a problem is like this. So construct a finite state automaton that accepts all strings starting with 0 and followed by a string with odd number of ones. Odd number of ones. Okay, so in the start we always need a starting stage. Okay, so this is my S0 and here I say start. Okay, now I want I want to start with 0, so obviously I want to start with 0. So this is one state. Now I'll see what to do with this. Okay, now this is one stage which also checks the number of ones we have. So here whenever we reach this state, we will say that okay, the number of ones at this state is always even. Okay, so when it is even, then this means that just one should take it to a final state. So I can say S2. Okay, but what if a 1 comes here? So I can say 1 is here, right? But what if a 0 comes here? So a 0, remember this state is counting whether a number of ones is even or not. So for 0 I will stay here. Okay, what if 0 comes here? So if a 0 comes here, I can still stay here because this is an ending state and here the number of ones is odd. Okay, okay, but there's another we have to consider something more. What if a 1 comes here? So if a 1 comes here, it's an automatic reject because we want to start our string with a 0. So we will create another state. You can say S4 and this is not a final state and we can say okay, stay there forever. Okay, so if a 1 comes in the start, then we will go to a state which is not a final state and we will stay there forever, which means that that string is not accepted. Okay, so this is how we connect this problem to this problem. Okay, so now let's do the reverse problem here. So now we have a finite state automaton like this. Okay, so then let's say this is our finite state automaton and we want to check what is the language it recognizes or accepts. So this is my first final state. How can I reach there? I can reach there by having 1 0 and then having a string of zeros, or I can have any number of ones here, then followed by a 1 0 and then any number of zeros. Okay, so first of all let's check this 0 and this any number of zeros. So this we already know that this is 0 concatenated with the clean closure of 0. Okay, this is the same thing as writing this guy that this is a 0 0 0 and so on. Okay, so this is this string, this string, this string. But what about this guy? This guy is, we have to have 1 1 then 2 ones, any number of ones, right? So I can also say, so this guy I can just say 1 clean closure, right? So this means that this guy now takes care of 0 1 any number of ones, then 1 0, then any number of zeros. So any number of zeros here, any number of ones here, okay, and I don't have to say this 0 here, because any number of ones means that it can be 0 ones, and this can be 0 zeros, but this 0 is already there. Okay, so this is where I have what we have right now. But then we can extend it to what? We can extend it to 1 followed this by 1 1, and then any string, and then any string. So this means I can follow this story by just 1 1. So I can say, if I can just repeat that here. So right now I have till here, right? So now I can extend it to just 1 because of this one, and any string after s2, any string can lead me to the final string. Can I say 0 1 cleans closure? Because 0 1 cleans closure takes care of any string, correct? But there's a problem. This also has an empty string, and if I am here an empty string and nothing comes, then I'm staying here, right? So then I have to say here x here, where x is either 0 or 1. So this means I have this story. I can have any number of ones, which can also be 0 number of ones, then followed by 1 0, and then any number of zeros, which can be also no zeros, followed by 1 1, then followed by 1 either 0 or 1, and then followed by anything, which can be an empty string as well. So this is the language. This is the language which is accepted by this state machine, and also it is written in my opinion very elegantly using our concepts of cleans closure. So this is it about finding further examples about finite state automaton and how language recognition is associated with it, specifically with the deterministic type. Okay, so hope it was easy to understand. Thanks for watching. Hope you liked the video.